Now we're going to talk about the three different coordinate systems. The rectangular coordinate system is the one that you're used to working in. In that case, x is shown here, y is shown here, and z is shown as going up. So the three variables are x, y, and z, and with all coordinate systems, the three unit vectors are orthogonal to each other, and x cross y is equal to z. The cylindrical coordinate system, I'm going to draw my x, y, and z just as before, so that you can see how the cylindrical and the rectangular coordinate system. In the cylindrical coordinate system, when we consider a point, that point is going to be defined as r, which is a radial vector. R comes out from the z-axis. So here is an r vector, here is the same r vector. So here are 2 points that have the same r vector. They're going to be defined by their r and their phi, which starts here at the x value and goes towards the y. So phi equals 0 is the x-axis. So these points, if they happen to be in the yz plane, are going to be defined by phi equals 90 degrees. And then they also are defined by their z value. So here is a z1 value, or let's put z1 down here, and here is a z2 value. So this point right here, P2, is going to have an r, a phi, and a z component. So the r value in this case might be 1 meter, the phi would be 90 degrees, and the z might be 3 meters. There's an example. P1, right here, might have a value also of 1 meter, 90 degrees, but its z value might only be 1 meter. The spherical coordinate system, let's again draw my x, y, and z to give us some perspective. The spherical coordinate system is going to have a radius, so here's a point right there. It's going to have a radius r from the origin. This time the radius is not from the z-axis, and you'll notice that I'm using a capital R instead of a small r. It's going to have the same type of phi, which again starts at the x-axis, and then it's going to have a theta term, which comes down from the z-axis. So this point right here is going to be defined as an r, phi, and z point. So it's going to have an r, a phi, and a theta. Sorry, I think I said z, but it's r, phi, and theta. This point right here might have a radius of 1 meter. The phi value, because it's in the xz plane, is 90 degrees, and theta, coming down from the z-axis, looks like that's about 45 degrees. Let's choose a point that's over here in the xz plane, and let's experiment with that a little bit. Let's call that P2. P2 is also going to have an r value, which perhaps is 1 meter. Theta in this case is going to, phi in this case is 0, and theta, again, is going to be 45 degrees, because that's how far down it is from the z-axis. So there's its theta. This could be also drawn as theta. This would be the theta value, like so. Let's choose one more point. Let's choose this value right here, P3, that's down in the xz plane. In that case, it looks like its r value, again, is 1 meter. Its phi value is about 45 degrees. Its theta value is 90 degrees. Here are the important limits. Phi goes from 0 to 2 pi. It goes around in this whole circle. Theta goes from 0 to pi. It just does 180 degrees like this. So be sure that you pay attention to those specific limits.